factoring is the opposite of multiplication. So we just were doing multiplying polynomials together. Factoring is opposite of that. So look, if I take this and say, well, it's 5 times x minus 2, we know we would take this and we would distribute, so we would get 5x minus 10. Well, factoring is the exact opposite of that. It's starting here at 5x minus 10 and saying, what can I pull out? So what's in common in each term that I could pull out? So you would have to look and say there's 2 terms. To factor out something, it has to come out of each term. So what's in each term that I can pull out? 5. So I pull out a 5. Now I write it, and then I'd say, okay, so technically, everyone, I divided by 5 out of each term. And now let's see what's left over in our first term. X, right, everyone? And then 10 divided by 5 is 2. So it'd be minus 2. And look at that. So factoring is just pulling it back apart. Now this and this are equal. Standard form and factor form are equal. Not one is being solved, not one is better than the other. So it's just learning how to do different formats. Now there is a future. In the future we are going to use factoring for a reason. That's why we're learning it. But understand, you're not doing anything. You're not simplifying it. You're literally rewriting it as something different. But you haven't done anything. You haven't simplified. You haven't done anything like that. Okay, so now here's one quick check. This is really good to recognize. Here's how to check if you have truly factored out the greatest common factor. So looking at 4x minus 16, let's pretend, just for kicks and giggles, that I didn't pull out the greatest common factor. Let's say I pulled out a 2. So then I would divide by 2, divide by 2. That would give me 2x minus 8. Now look inside your parentheses. Now that it's smaller, we can kind of see better that something more should have come out. So what do they both still divide by? 2. So that's actually an easy fix. Let me show you how to do it. You'd say, okay, I need to actually pull out another 2. That would be multiplied in front. And then you would divide by 2, divide by 2. So we would have 2 times 2 in front, which is 4. And now 2 and 2 divide out, and we would get x. And then that would divide out to be minus 4. So it's an easy way to check if you factored out the greatest common factor. Look inside your parentheses and say, is there anything more that could have come out? Does that make sense? Easy fix, though. Okay. Okay, so factors. So what would we pull out in this one? 7z. So you'd write it, then divide by 7z. Divide by 7z. I highly recommend writing that, but make sure you actually write 7z. I always have people, once they start going, just say, oh, divide by 7z, and then they have the 7z evaporate into thin air. Well, it's got to be somewhere, so it's on the outside. Now, 7's divide out. Z squared and z divide out to become a z. Moving on, negative 14 divided by 7. Negative 2, and my z's are gone. And I'm done. Now let's say on the test you're like, did I do this right? Well, factoring is the opposite of multiplication, so you can multiply it back together and see if you end back up at the start. So we know we've done it right. If you do multiply back together, we end right back up at the beginning. Okay, looking at this one. This one has 3 terms. 1, 2, 3. What's the greatest thing in common? A 2 and a y. So I'd write 2y, parentheses, divide by 2y, divide by 2y, divide by 2y. So then left in the first term, 6 divided by 2 and becomes a 3. Y cubed and y divide out to become y squared. Negative 14 and 2, negative 7. Y squared and y divide out to become a y. 10 and 2 divide out to become 5, and my y's divide out. And I'm done. I would check in the future to see if this quadratic factors even more, but we're not learning quadratic factoring quite right now. Not quite yet. Okay. Okay, factor. Anyone up here, what would I pull out? Okay, why did you say negative 3a? Yes, so you're saying if there's ever a negative in your leading term, he's remembering rules from Sec 3, everybody. If there's ever a negative in the front first term, we always are going to factor out a negative with our common factor. So you'd say, I'm pulling out a 3 and an a, and because there's a negative in the leading term, I'm going to pull out negative 3a. That's just something we always do. So divide by negative 3a, divide by negative 3a, divide by negative 3a. So then left in our parentheses, negative 3 and negative 3 divide out. A cubed and a divide out to be a squared. Positive 6 divides by negative 3 and becomes negative 2. A squared and a divide out to be a. Negative 12 divided by negative 3. Positive 4, right? And then a's are gone. Okay, so what would I factor out in this one? Negative 5y, because of the negative in front. Now let's pretend that wasn't there. Let's pretend it wasn't there. You wouldn't say, oh, I'm going to factor out out a negative because there's a negative. No, it's if the negative's in the leading term. So there is a negative, so we pull out negative 5y. Pull out negative 5y. So then left is y plus 2, because that was a negative 5y we pulled out. So y plus 2. Okay, in this one, a little bit harder greatest common factor, but still not too bad. What should we pull out? Look at your numbers. 4, 10, and 18. 2, a squared, a, and a cubed. A, we can only pull out an a. B squared, b cubed, b to the 4th. B squared. So then write it. I highly recommend going back and writing what you're dividing by. 2ab squared divided by 2ab squared. So let's go ahead and do this. 2a, and then the b's are gone. Minus 5. A's are gone. B is left, right? Positive 18 divided by positive 2. Positive 9. A cubed and a become a squared. B to the 4th and b squared become b squared. Now look in your parentheses. 2a, 5b, 9a squared b. Was there anything more I could have pulled out? Not a trick question. Was there anything more I could have pulled out? No! This one has an a, this one has a b. There's nothing more here. Everybody see how I'm just checking? Okay. Alright, do we get the picture with these? Moving on then. What would I pull out here? Negative 2b. Okay, good. Now here is another factoring method. Okay, so the first thing we check with factoring, period, is there a greatest common factor? If not, you go on to say, well, what type of factoring am I doing then? If there's not a greatest common factor, what type? So here's our first rule we're learning. We're going to learn a lot. The first rule is, if you have 4 terms, now look, 1, 2, 3, 4. If you have 4 terms, we factor by the method called grouping, or at least we try. So you'd say there's 4 terms, it's something you need to memorize. That's how you tackle factoring 4 terms. You factor by grouping. So this is what we do. We group the first 2 terms, everybody. We group the second 2 terms. And then we're going to factor out the greatest common factor of each group. So now you'll just focus on this group. You're going to pull out the greatest common factor in that group. What would it be? Pull out an x squared. So now, right? Pull out x squared. Then it divides by x squared. Divides by x squared. So then left would be x plus 3. Now you'll focus on your next group here. Pull out the greatest thing in common. Watching for negatives in front, but there's not. So what would be in common here? Positive 2. So then I divide by 2, divide by 2. So left would be x plus 3. Now everybody listen. If it truly factors by grouping, this will always happen. Inside of your parentheses will be the same. If not, you've done it wrong, or it does not factor by grouping. It has to be the exact same. If there's a sign that's different, that's wrong. You cannot factor unless it looks exactly the same. And it does. That's what I call, quote unquote, it's like our safe haven. We know we've done it right. Like, okay, from here, we can say we've done it right because that's the same. So now, you're at the step of factoring out the greatest common factor here. Okay, so everybody look. Here's a term. Here's a term. In each of those terms, what's in common? Okay, so we're pulling out x plus 3. Now we're only pulling out one x plus 3. And then we go back and say, okay, what's left in our parentheses? So we're going to divide by x plus 3. Divide by x plus 3. So in my first term, the x plus 3's divide out, and we get a x squared. Then my x plus 3's divide out in my second term, and I get a plus 2. And I'm done. That's what I always have people do. They write, well, I pull out 2x plus 3's. No, that's not how it works. You pull out 1x plus 3, and that's why you were able to divide it out. Does everybody understand that? Don't write x plus 3 squared. Okay, let's look at this one. So it just is going to say on the test factor. You're going to have to recognize there's no greatest common factor, and it's 4 terms. So I'm going to try factoring by grouping. Okay, let's pull out the greatest thing in common here. 3x, so then divide by 3x, divide by 3x. So left in my first term here is 2x plus 3. What's the greatest thing in common here? Negative 5. You pull out the negative because the front had a negative, so divide by negative 5. Divide by negative 5. So then left is 2x plus 3. We know we've done it right because look in your parentheses, so pull it out. 2x plus 3 pulls out. So I'm not going to rewrite divide by 2x plus 3, divide by 2x plus 3, because we know what happens. It divides out. So then left is 3x minus 5, everyone. We good with this? Factoring by grouping? Okay, looking at this one. You'd say there's no greatest common factor, but there is 4 terms. So I try factoring by grouping. What would I pull out here? 5, divide by 5, divide by 5. So left is x plus y. Pull out a b, a positive b, so divide by b, divide by b. So left is x plus y. It's the same, so I can pull it out. Pull out x plus y. It divides out, leaving me with 5 plus b. Does everybody feel good? Same steps every time. Okay, I think we get the picture with this. I just want to point something out. People always have an issue with this part. So, factoring by grouping, let me just show you. The reason I put this one up is because when I did it early morning, people were doing this wrong. What would be in common here? X, right? Well, divide by x, divide by x. Now watch, don't be the person that does this wrong. So that would be a 2 and an x, true? Yeah. People are saying then that's gone. Yeah, it doesn't divide to become 0. You're right. It divides to become plus 1. Then right here we pull out negative 5. Divide by negative 5. Divide by negative 5. So then left is 2x plus 1. It's the same. Pull out 2x plus 1. It divides out, leaving me with x minus 5. Okay, factor. What would I pull out? Isn't this one actually not factoring by grouping? It's not factoring by grouping. There's not 4 terms. But it is greatest common factor. What's the greatest common factor up here? So we'll pull out an a minus 3. So then it divides out. And left would be 4a plus 5. So it's just like starting at that one step in factoring by grouping. So what's in common here? Good, w minus 5. So it divides out. And then left is, careful, we have this w plus 2, don't we? Now look, watch, people were doing some weird things. We have a w plus 2 left. Now it's a plus sign, isn't it? So it's plus, not multiplication. And then left here was 2w plus 1. Now look inside those parentheses. Can't you combine like terms? Yes. Even though there's parentheses, it's just addition, isn't it? So over here we still have w minus 5. And now we'll combine like terms. W plus 2w. 3 w's. 2 plus 1 plus 3. Now looking at your final answer here, is there something more I could factor out? Yes, 3. So we always check our final answer to say, is there more I could have factored out? There's a 3, a greatest common factor. So everybody, I pull out numbers, they pull out in front. It's just prettier. Now we're only pulling 3 out of this, aren't we? So we're pulling out a 3, put it in front, so I still have w minus 5. I pulled the 3 out of this. So divide by 3 there. You wouldn't divide this by 3. Does everybody see what I'm saying? Mm-hmm. So then left would be w plus 1. Yes, because looking at it, it's factored completely, right? Okay, what's in common? There's a reason I'm doing it. We're almost there. What should I pull out? X plus 3. There's 2 terms. That term and that term. You pulled out x plus 3. So we're dividing by x plus 3. We're dividing by x plus 3. Now let's see what's left in our parentheses. 3 is still there. And then we still have an x plus 3. Now careful, this is a minus sign, minus 5x. Is that it? Okay, now you'd say, I can actually continue to simplify the inside because I can distribute. That would be 3x plus 9. So now we have an x plus 3 on the outside, but inside, combining my terms, 3x minus 5x is negative 2x's, and then plus 9. Now, is that considered factored completely? Why do you say no? Because there's a negative in front, so we would actually probably pull that out. We would pull that out, everyone. So we'd say we're going to pull out a negative 1 in front, just like we did with the 3. There's still an x plus 3. So we divide it by negative 1, divided by negative 1. So then left would be 2x minus 9. Yes. Uh-huh. So we pulled out an x plus 3 right here, right? This one had a square, so there was still 1x plus 3. But this one did divide out completely. Does that make sense? Okay, awesome. Now looking at this one, guys, story problems cannot scare you because a lot of times it's just asking the same thing. Let's read this. Given the surface area of this cylinder is this formula, S is equal to 2 pi r squared plus 8 pi r, factor. Is that asking you to do anything different? No? So how would we factor that? So you're saying factor out the greatest common factor, which would be a 2, a pi, and an r. So write it. Divide by 2 pi r. Divide by 2 pi r. So then left in our parentheses is r plus 4, right, everyone? Then you would say, if I said to you, great, now find the surface area when the radius, is equal to 3. What would I do? Plug in 3 and calculate it. And leave your answer in terms of pi. So if we did that, it would be like, okay, that's 2 times pi times 3. And then 3 plus 4. So we actually are dealing with 2 times 3 is 6 pi. And then we have a 7. So isn't that 42 pi? Right, everybody? Awesome. Okay, if I said to you, write the area of the shaded region in factored form. Okay, everyone looking at this. Here's my shaded region. Don't look at something that looks a little bit intimidating and just say I can't do it, because it's actually very intuitive. If I only want this area, just in general, don't tell me the actual, like, oh, you're going to take this and do this. I just want to know, if I want to find this area, how would I go about doing it? Yeah. Yes, he said find the area of the whole thing, the rectangle, subtract off the area of the circle, and then wouldn't that be the leftover shaded region? Thank you for thinking. Yes. So let's find the area of let's pretend the circle's not there. How do you find the area of a rectangle? Length times width. So let's find the area of the rectangle. Looks like it's, oh wait, it's a square. Sorry, it's a square. I drew it as a rectangle square. We're going to call it a square. So it's 4x, 4x. Actually, no, it's not a square. It's not a square. Good point. So you're saying, what are you saying, Emma? What would this length be? Wait, you times them? It'd be 2x. Yeah, but you're on the right track. Yes, you're right. 2x. Okay, good. So our length and our width, so length times width, our area of this is 8x squared. Okay, good. Now let's find the area of the circle. So area of a circle is, you have to know without being told, pi r squared. So that'd be pi times, what's our radius? X squared. So isn't that pi x squared? So that would be our area is pi x squared. So you said you take the area of the rectangle, 8x squared. We'd subtract off pi x squared. Then it says to write it in factored form. That is our answer, but what would we factor out? Pull out x squared. So divide by x squared, which is 8 minus pi. There's our statement. Okay, good. I think we get the picture with the area ones. That was really good. Okay, so ready? Work on 5.4 before we go on to 5.5. Here are the problems that you will do. Then I would go back to 5.2 because I did not assign these ones, but you very likely could be tested on them. So I'd go back to 5.2 and do 101, 102, 105, and 106. So I'm going to give you a while to practice these methods.